Hello guys, welcome you all for this end-to-end session of AIML, where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying a lot and learning a lot each and every day. We are learning, we are enjoying each and every day. Hope the same thing for you guys. So before going for this session, make sure you guys watch all the previous session videos so that you can have a better understanding of what we are talking. And one more thing, guys, please make sure you subscribe to our channel because like every day just we are just posting a new video. So you will be getting notification whenever you just subscribe and turn on the notification for us, so you're not gonna miss any of the things. Okay, so and on one more thing, there are like 1,000+ quizzes. Okay, just I try to attend it. It is in our YouTube and it is in live also. Okay, yeah, let's move on to today's session. So we are just on to the last, we will say last series of machine learning. Okay, not like AML, for only machine learning part. Okay, so it's reinforcement learning. Last session we have introduced you what is reinforcement learning, what are the key terms in reinforcement learning. Today we're gonna continue it. Okay, let's without wasting any time, let us jump into today's session. It's all about deep reinforcement learning. Let's see what it is. So deep reinforcement learning, neural network used to approximate the value function or policy function in R. That is reinforcement learning. Experience replay, a technique used to improve training efficiency by randomly sampling past experiences. Policy gradients, a method that for optimizing the policy function directly by adjusting the parameters of the neural network. Same example. Okay, if you guys have followed the previous one, then it will be easier for you guys because I'm gonna use the same example. That is Super Mario game. Okay, what is deep reinforcement learning? Let me make the things very simpler because like we're gonna see a separate session for deep learning where you guys gonna see what is deep neural network. Okay, now putting in a simple way, it gonna be 100 times of any machine learning algorithm. We're gonna use it for training our agent, that is Super Mario character. Experience relay, a technique that is used to improve the training. Let makes it simple. It's simple. Okay, whenever we hit on a tortoise, we can able to understand, okay, if the Super Mario character hit a brick and it becomes a tortoise, then the next time, based on its experience, it not gonna hit that brick because the tortoise go and hit the character, right? And our life will be like over. Okay, then what is meant by this policy gradient? A method for optimizing the policy function, like directly by adjusting the parameters of the neural network. Simple. Okay, we are adjusting the things, right, in order to save our life of Super Mario. Similarly, that is what policy gradient. There will be some set of policies that we need to follow so that we can safeguard our life and we can improve the character learning. Okay, hope you guys can able to understand. Only what change here we are doing is we are introducing a deep learning model to make the things learned by the character, that is agent, where in a Super Mario game is the Super Mario agent. That's it. Okay, so hope you guys can able to understand. If you guys doesn't understand, please make sure you watch the previous video, or even though if you guys doesn't understand, just make sure you guys pick in the comment section. We will take up and we will solve your doubts. Okay, so yeah, sir, over to you.
Yes. So deep reinforcement learning. So whatever was there in reinforcement learning, whatever we've discussed here, we'll go deep. Okay, that is the difference. So how we go deep? We use neural networks. So first element is using neural networks and used to approximate the value function of the policy function in RL. That is what we have to use. We'll use uh, neural network used to approximate the value function or the policy function in RL. So that is what first step. Then we have experience replay. So the technique is used to improve the training efficiency by randomly sampling past experiences. So okay, that is the second step for deep reinforcement learning. Then we have policy gradient. So method for optimization the policy function directly by adjusting the parameters of neural network. So you know gradient descent and all those things, we use it for parameter tuning and stuff. We use it, right? So we try to optimize using all these. So this is how the policy gradients also okay. So they have these functions. So keep learning deeply, guys, with long-term objective function, and give us feedback for each session so that we can improve. We are open for all kind of feedbacks, so that we can improve each session with learning objective. Keep learning deeply. Thanks a lot.
Yeah, sure, sir. Let's move on to the next thing. Okay. Oh, okay. What are the challenges and limitations that we are having in reinforcement learning, guys? As sir and myself is mentioning, right? It's a gamified environment in reinforcement learning. Let's see what are the challenges and limitations that we are having. Data scarcity. Collecting enough data for effective training can be challenging, especially in a complex environment. Yeah. In order to make the Super Mario game automated, we need to have frame by frame information of entire game through walkthrough of game. Okay, so it's very difficult, right? We need to take each and every frame of data and we need to store it and we need to train it, guys. It's gonna be, I will say, it's gonna be like a tedious process. Okay, that's the reason we have covered working with data as a first thing. Okay, that is what here gonna happen. That is data scarcity. Overfitting. The oral agent may overfit to the training data, leading to the poor performance on the unseen environments. Okay, yeah, overfitting sometimes occurs. What means, whenever we train the model, right, using the gamified environment, it gets to memorize the thing rather than learning. Okay, it memorized everything so that whenever the new environment is given to the agent, it will not able to act. So that is the reason what is overfitting. Okay, you guys already know what is overfitting and underfitting. I'm just explaining in a gamified way. That's it. That's it. Exploration versus exploitation. I hope like you guys know. Okay, we have discussed this. Okay, balancing exploration, trying new actions, and exploitation, that is taking action that has been successful in the past, is crucial for learning optimal policy. Yeah, in order to win the game, Super Mario game, we need to do exploration, that is new actions we need to take, and also we need to go for the exploitation, that is whatever things that goes good, right, we need to continue that, then only we can get the achievement. Okay, so yeah, these are the challenges that will be that: data scarcity, overfitting, exploration, and exploitation. Yes, sir, over to you.
So, challenges and limitations, guys. There are three elements which we need to understand. So, there are challenges and limitations. Data scarcity. Collecting enough data for effective training can be challenging, so especially in complex environment. So, that is the first factor, challenge. And then overfitting in RL agent may have overfit to the training data and leads to poor performance on unseen environment. Again, like same way, the overfitting concept, unseen and patterns in machine learning we have learned. Here, the unseen environment, because that is where the model learns from, the environment, right? The experiences. So that if your model is not uh, like trained well on a right data, and like it leads for poor performance because it has to learn, huh? So that is the objective. So then we have exploration versus exploitation. So the balancing exploration, trying to new action, and exploitation, taking action that has been successfully in the past. So we have to use all these. So model has to use that. It is crucial for learning optimal policy. That is very important. Okay. So don't worry. Don't if you don't understand certain fancy words like policy, and also policy is just the instructions given to the agent to perform certain tasks. That is what it is here. In normal life, policies again mean the same thing, but they are like, if you see government policies and all, they are again the instructions for people to do certain work. So here it is different, like agent has to do the intelligence system or whatever model you are creating, that has to optimize according, and learning optimize policies and all. This term called policy or policies are related to the instructions that how agent has to learn or has to perform certain tasks. Okay, keep learning deeply, guys. Let's move to the other session.
Yeah, sure, sir. Let's move. Okay. Let's see the applications of reinforcement learning in data science. And before going further, I hope like what I'm gonna do, what I'm gonna say everyone. Okay. Because like the slide is this much. So I have only this kind of application. So wherever industry, whatever the work that can be automated by using this reinforcement learning. First is recommendation system. Yeah, personalized recommendation system based on user preference and past experience we can do by using reinforcement learning. Fraud detection. Yeah, identifying fraudulent transaction by learning patterns of supervision activities. That also we can do by using supervised learning, like unsupervised learning. That is one of the thing that is reinforcement learning. Resource optimization. Yeah, we can optimize resource allocation and scheduling in areas such as cloud computing on logistics. That we can do by using this kind of unsupervised learning. That is reinforcement learning. Robotics. I will say this is a broader environment where we will be applying this reinforcement learning, because like robot is an agent, right? And environment is our real world, and the actions is like picking the object, moving the robot, moving hands, everything is an action. Whenever it is going to do something uh, which is different what we are communicating, then it is called as a punishment for us. So we need to give a punishment. Okay, if it is doing whatever the things that we are doing, then we need to reward it. Okay, so this is what robotics is. A I will say it's a proper field that explains this reinforcement. Okay, it enables robots to learn complex tasks and navigate complex environment automatically. Okay, autonomously. So yeah, these are the four things that we are having as an application for reinforcement learning for this slide. Okay, as I'm mentioning, there are n number of field which has an application of this reinforcement learning, especially the robotics kind of things. Okay, so yeah, sir, over to you.
So, application of reinforcement learning in data science and AIML, guys, recommendation system is the best way where we can use the reinforcement learning. It is personalized recommendation based on user preferences and past behavior. Then you have fraud detection, which is like it identifies fraud transactions by learning patterns of suspicious activities. Then you can use it anywhere in financial system, recommendations anywhere where you need recommend products and services or anything. It is, you can apply it n number of industries. So resource optimization, you can allocate resource, schedule areas that cloud computing and logistics, you can use it there to optimize the objective function and the resource and time and all. Robotics is a big field, a vast field where you can use the reinforcement learning, enable robots to learn complex tasks and navigate complex environment and normally, like in Mars rover, it was the best example of robotics, like how they have explored the Mars using Mars rover and other robots with specific instruction and objective function to solve the and it's a big thing where you can use reinforcement learning with other algorithms. Okay, so keep learning deeply, guys. There are n number of like industries where you can apply this. Okay, keep learning. Thanks. Let's move to the other session.
Yeah, sure, sir. Let's move on. Okay, let's conclude it. Okay, conclusion and future direction. Reinforcement learning is a rapid evolving field with great potential to address complex data science challenges. Future research will focus on developing more effective and robust RL, that is reinforcement learning algorithm, tackling the challenges such as data scarcity and generalization. Okay, let me say one thing. It's not like a future; it's a present thing that is happening, right? Can you guys able to understand that? Okay, presently we are having these innovations. Okay, so this is what all about reinforcement learning. As I have mentioned, I'm going to explain these two games by using this reinforcement learning, right? You guys, whenever there is an interview question, like actually the session is over. Okay, when you guys get an interview question, what is reinforcement learning? This is the way that you need to explain. Okay, what is reinforcement learning? The agent act upon the environment. Based on the action, you're going to get the punishment retrieval. That's it. We're gonna say an example of Super Mario game where the character that the agent gonna be a Super Mario character that gonna act upon the environment. That is a gaming environment. Based on its action, up, down, left, right, it's gonna get the punishment or reward. That is either it's a tortoise or it's a coin. Okay. We had one more example, right? Snake game. In a Nokia phone, we will be having a snake game, right? What is the character there? Snake is the agent, and what is the reward it gonna get whenever it eats a food, right? It gonna get the reward. Whenever it gonna eat itself or on the wall, it gonna get the punishment. That is called as reward. Okay, and the agent where it is revolving around, it's called as the agent revolving around the world is called as environment. That's it. Okay, simplified things, okay, and it's a gamified things, okay. Hope you guys are able to understand. If you guys have any doubt, just speak in the comment section. We'll take up and we'll solve your doubts, okay. So yeah, sir, over to you.
Yeah, so conclusion and future directions. RL is a rapidly evolving field, guys. So great, it has a great potential to address in complex data science challenges and AIML or robotics, as we have mentioned, the different n number of industries. Future research will be focused on developing efficient and robust RL algorithms. There will be new algorithms. You could be one of the designer of algorithms, guys, if you learn with us deeply, because we are designing new program where you guys are going deep into like the mathematics, and then we are going for, we'll have a special program after that, 1 year program, where we'll go and learn how to design algorithms, how to design from scratch and become a world class algorithm designer. So for that you need to become a deep AI researcher with long term objective function. So let's come to this particular point. So tackling the challenges and the data scarcity and generalization. So we have to understand the future aspects, and there would be n number. This is the start, guys. So keep learning deeply these algorithms and the future aspects, and keep learning from the right source, and keep learning with huge hyper focus and attention and long-term objective function, with patience, persistence, consistency and perseverance. So learn all these concepts very deeply, guys. They are unique and they have unique application limitations, and they have limitations, they have advantages and disadvantages. So you need to know the limitations of these algorithms and where to use, where not to use, right? So keep learning deeply, and there is, and have a future perspective. Keep learning deeply, and we are already applying these algorithms right now, and in future we have n number of algorithms coming, and you could be one of the designer of future algorithms, and which people can use, and you will be remembered for centuries, okay, if you design original algorithm in computer science, and you might get Turing award. So have very high goals and keep working for those goals deeply, okay. Let's move to the other session. Thank you.
Yeah, guys, that's all about today's session. So hope you guys have enjoyed. So yeah, as I was mentioning, let's make history, okay, by learning this data science, okay. So yeah, guys, take care until next session. Bye, guys. Take care. We'll all meet in the next session. Bye, guys.